All right, so these questions can get really confusing, so you kind of have to make a strategy you follow every time. And this is my strategy. I always sketch first. Secondly, I'll just make the functions equal each other and then solve the resulting equation. Because the x values of this are the x values of where the functions equal each other, so that's where the lines meet, these are the x coordinates of the intersections. So these are the roots of that resulting equation. So the x coordinates are the roots. So I'm just going to label them alpha, beta, gamma, and delta, just like we did before, because we know certain rules about alpha plus beta, alpha times beta, like we know the certain stuff about the sums and products of these roots, because that's what we learned in exercise 10F. And then if they tell you the intersection is a tangent, then you have repeated roots, and we're just going to call those alpha and alpha every time. You get more complicated kind of situations later, and we'll talk about that later. So if we have a look at 1a, show that the coordinates of these two lines, okay, well, we're going to start off by sketching. Hang on. I've got the line y equals x squared takes 6x. If I factorize that, that's y equals x outside of x takes 6. So already I know it's a parabola and its intercepts are 0 and positive 6. And I've also got, and I'm going to do this in a different colour, y equals 2x takes 16. So that's a straight line. Its y-intercept is negative 16. Its x-intercept is 0 equals 2x takes 16, so x will be 8. So, let's sketch these. We're not going to do a great job at all. 0 and negative 6, it's going to come through like that. I haven't figured out anything else about it. So that's y equals x squared takes 6x. And then I'm going to do the line 2x takes 16. Well, I know it goes through the the y-axis at negative 16. And that's going to cut through there, yeah? Now, I've only done a vague job, so this line may have actually, like it could have gone up like that. It could have missed the parabola completely. I'm just going to do that. And I'm going to call the x coordinate of, this is y equals 2x takes 16. I'm going to call the x coordinate of this bit, I'm going to call it alpha because that's my first root. And I'm going to call the x coordinate of this bit beta. So that's me sketching to start with. Now they actually want me to show that it satisfies this new equation. So essentially every time you get that, you're going to make the y's equal each other. So we've got x squared takes 6x equals 2x takes 16. Take everything over to the left. I get x squared take 8x plus 16 equals 0, and I've shown it. Okay, for 1b, they actually want me to solve this equation. So I've got x squared take 8x plus 16 equals 0. You could put this straight into your quadratic formula, or you could factorize. So what times is together to give positive 16? That adds to give negative 8. Well, x take 4 and x take 4. So x equals plus 4 repeated. Now, because it's repeated, it's a tangent. So it's x take 4 squared equals 0. So it is a tangent because it means that alpha equals positive 4 and beta equals positive 4. And that's only going to happen if instead of the line coming off there, it kind of touched right there, you know, and I only hit it once. And you get rid of that. Tangent because the roots alpha equals beta equals positive 4. So, I mean, those two roots of it are at the same point. So it like literally only hits it at one point. And y equals 2x takes 16 only intersects with y equals x squared takes 6x at exactly 1 point. So the point T, well, we know x is positive 4. So y equals, we could sub this positive 4 into either of these equations. One's going to be easier than the other. I'm going to do 2 times 4 takes 16, which is negative 8. So T is 4, comma, negative 8.